Hi, I'm Sean Moran with ACC GIS, and our topic today is raster path analysis. Raster path analysis allows us to analyze the spatial relationship between connected cells. It's most commonly used to support path or corridor analyses where you want to locate the optimal route between two or more locations. A great example of corridor analysis is this Migrations in Motion interactive web map created and published by Dan Majka with the Nature Conservancy and researchers from the University of Washington. The flow lines on this map show the average direction mammals, birds, and amphibians need to move as hospitable climates shift across the landscape. Mammals are pink, birds are blue, and amphibians are yellow. I believe the flow lines were constructed by mapping existing and predicted habitat as raster data layers with a 50-kilometer cell size. Researchers then used least cost corridor analysis to predict the most likely migratory path for animals, birds, and amphibians towards higher, cooler, and wetter climates. The result is this beautiful flow map that intuitively conveys the geographic impact of climate change on the animal world. Check out the map for yourself by clicking on this lecture slide or searching the web for Migrations in Motion. By the end of this topic, you should be able to differentiate between Euclidean and cost distance, explain how cost is used to perform raster path analysis, list analytical products you can create from a digital elevation model, create analytical surfaces from a DEM, and perform a least cost path analysis. As we wrap up our discussion on analyzing raster data, this week we'll focus on connectivity and custom analysis. First, connectivity, where we'll analyze relationships between connected cells, and then custom, where we'll use custom tools to analyze spatial relationships between cells. Now, to analyze the relationship between connected cells, you need to be able to analyze distance. And we can use the distance tool set and tools like distance accumulation to do that. First, you need to create a distance from a source raster. The sources can be vector or raster, like points representing towns, lines representing roads, or polygons representing buildings. Or you can even use a raster, for example, representing water features, as long as all the other cells in the raster are valued as no data. Now, the distances are measured from cell center to cell center, and these tools output a number of raster datasets that are required to support path analysis. Now, there are two primary types of raster analysis for analyzing distance: Euclidean or straight line distance, or cost distance. And we'll talk about each of these. Euclidean raster distance is the shortest distance. It doesn't take impedance into account. And the types of rasters that are generated from this type of analysis include Euclidean distance, Euclidean direction, and Euclidean allocation. Euclidean distance finds the shortest distance from each cell to the closest source. It's almost like you're laying a ruler down to measure distance. And if you look at the example on the right, you can see I've got my source grid with my ones and two representing the source, and then my Euclidean distance grid as an output, which is calculating the distance of every cell in the raster from the source cells. And if you look, for example, at the row on the very bottom of the Euclidean distance grid, you can see how it works. The cell in the lower left-hand corner is 0 because that's the source. That's where you start, and it's 0 distance. And then as you move from west to east or left to right, notice that the distance grows by 1 for each cell you move to the right. 1, 2, 3, 4, and 5 until you get to the cell that is farthest away in the lower right-hand corner. Now, Euclidean direction assigns the direction of each cell in degrees to the nearest source. It's almost like each cell points back towards the source. So in the example on the right, if you look at the source grid and then look at the very top row in the output Euclidean direction grid, and you'll see that we have 3 ones that represent the source in the top there, and they're 0 in Euclidean direction because they are both the beginning and the end. But if you look at the cell in the very upper left-hand corner, you can see that it has 90, and that's because it's 90 degrees back to the source cell. And if you look on the other side, you'll see there are 3 cells on that top row there that are all 270. And that's because it's 270 degrees or west back to the source cells. Last, Euclidean allocation just assigns each cell to the nearest straight line source. And so if you look in the lower right-hand corner of the image, you can see that each cell is assigned to the closest source cell. Here you can see a three-dimensional representation of these 3 types of rasters: Euclidean distance, Euclidean direction, and Euclidean allocation. Euclidean distance, again, is just the straight line path from start to destination. In the upper left-hand image, that's from source to A. Or the image in the upper right hand, I've got 3 different sources and 3 different destinations, but they're all straight line. There you can see Euclidean direction in the lower left-hand corner, and then of course Euclidean allocation with the cells being allocated to the 3 closest start or source cells. And so while Euclidean distance analysis is about the shortest distance, it doesn't take any impedance into account. Raster cost distance is about finding the cheapest distance, not the shortest distance. So impedance counts. And there are 4 different types of raster that we utilize or we generate as part of cost distance analysis, including cost surface, cost distance, cost backlink, and cost allocation. Cost surface is the raster where each cell value represents a cost. And if you look at the example on the right, you've got your source grid, and then you've got your cost grid just below that. And so rather than each cell costing just 1 to move across it, the cost varies depending on the value of the cell. And you utilize the source grid and the cost grid to generate the cost distance grid, which calculates the least accumulated cost distance for each cell to the nearest source over a cost surface. So if you look again at the example on the right in the cost distance grid in the upper right-hand corner, you can see on the very bottom row, it's no longer 1, 2, 3, 4, and 5 as you move from left to right across that bottom row. Now the value changes depending on what the value of the cost cell is that it is passing through. Now again, the cost backlink defines the neighbor that is the next cell on the least accumulated cost back to the nearest source. So basically, it's every cell looking back across the least cost path to the starting or source cells. And then last, cost allocation assigns each cell to the least cost cell.